Hello and welcome back to Data Analysis and Visualization. I'm Javita Christie, and in this video, we are going to study different file formats in GIS, which I introduced to you in my previous video. So let's begin. To facilitate different types of analysis and outputs, GIS accommodates two main file formats, raster and vector. Since these are the main two file formats types used in GIS, both proprietary and open source GIS applications have been specifically designed to support each. So raster and vector are the two main types of file formats that can be used to show spatial databases. And that's why whether you use a open source application or you use a proprietary, that is a paid GIS application, both of them would be supporting the raster and vector file formats. Raster data is broken up and plotted out along a two-dimensional grid structure so that each grid cell gets its own attribute value. Okay, so it is a two-dimensional grid structure, which means there are boxes and there is X and Y axis as usual, but there are also boxes created. So think of it as a computer screen with pixels. So it looks like that. And also if you think of those old video games that used to be there with in old mobile phones, which were black and white, those video games used to have this type of a format. Although most people know that rasters are used to store image data in digital photographs, very few people know that the raster file format is useful for storing spatial data as well. So raster file format is usually used for images to store digital photographs because, like I said, pixels, right? But few people know that it is also used for storing spatial data as well, which means location, geographic coordinates, and shapes. Raster files can be used to store data for only one attribute at a time. In GIS, data for a single attribute is stored and plotted in a two-dimensional grid where the horizontal dimension represents longitude and the vertical dimension represents latitude. Okay, so you cannot store multiple attributes at the same time for the same kind of data. What you have to do is store one attribute at a time. So for example, if that attribute you're dealing with is location, which means you have latitudes and longitudes, then in the GIS data, there will be a two-dimensional grid if you're following the raster form. And the horizontal axis, which means your x-axis, would show the longitude, and the vertical dimension, which is your y-axis, would show the latitude. Digital photographs and Doppler weather radar maps are two common examples of raster files in the modern world. So digital photographs still use raster formats just because even though mobile phones used to have this type of games in black and white, and just because such phones are obsolete doesn't mean the raster format is obsolete. It is still used in modern day for digital photographs as well as for weather radar maps, maps that show sort of a radar showing which areas are heated and which areas are cooler. So those kinds of maps also use this type of a raster format. Now, vector format files, on the other hand, store data as either points, lines, or polygons on a map. So this is something different. It's not like raster format, which uses grids and axes to store all this data. Vector format stores data as points, lines, or polygons, as we saw in the previous video as well. Point features are stored as single point records plotted in geographic space. Okay, so single point records that do not require multiple points. So if you're plotting something like a name of a place or something, for example, you're plotting a McDonald's store in a city, then how would you represent it on the map? You would just put a small dot, right? So that is a single point. It's a single point value. It has only X and Y, only one point, and that's why it would be plotted using a point. Line and polygon features are stored as a series of vertices that comprise each record plotted in geographic space. So if you have say you want to plot a river or something, a road, for example, then you will have multiple points and you'll point and you will plot that in your map. And if you had to plot an entire city or a country, then you might want to use polygons, because then also you would be dealing with multiple points. For data in vector format, GIS can handle tens of attributes for each record stored in the spatial database. Okay, so GIS can handle, if the data is in vector format, GIS can handle very easily tens of attributes for each record stored in the spatial database. Google Maps, modern digital graphics, and engineering computer-aided design, which is popularly known as CAD, drawings are some prime examples of vector graphics that use in the real world. Okay. So if it is vector format, lots of attributes can be processed at the same time by GIS. And some very good examples of vector format used in modern day are Google Maps, which we all use every day, and modern digital graphics, engineering computer-aided design drawings, which are known as CAD drawings. So all of these are using the vector format today in the modern world. To conceptualize the raster versus vector idea, imagine that you have some graphing paper and a pencil, and you want to draw a map of a street that's in your neighborhood. So now what we're trying to do is, understand when to use raster, when to use vector format, and when not to use a raster format and when not to use a vector format. So it's important to know because there are two different formats. So now to do that, you have to imagine that you are using some sort of a graphing paper and you've got a pencil, and what you want to do is draw a map of a street that is in your neighborhood. Okay, so you just want to draw a map of a street that's nearby. You can draw it as a series of polygons, one representing the area covered by the street and the others representing the parcels that are about the street. So, for example, if your street is having, different blocks of buildings, then, you would first show the street as a big polygon. Then within that polygon, you would show all these blocks of buildings using more polygons. So there would be one big polygon, which would be your street, and there would be one smaller polygon, not one, many smaller polygons within that big one, showing all the buildings and shops and everything that you have. Okay. You could also fill in the squares of the graph paper one after the other until you cover all the areas with one single multicolored surface. So because it's a graphing paper, if you remember from your school days, is the kind of paper that has those grid lines. It has x-axis, it has y-axis, and I believe there are about, there are boxes on that paper of 1 centimeter. I think it is 1 centimeter. So those kinds of boxes are available. So just if you wanted to use that, then you would just fill all those squares of that paper with different colors. Maybe one, if you have a building, then you might want to color it brown. If you have a shop, you might want to color it red or something. So if you do that, you could still create a map. Now, this is an example of what it looks like. The raster format is almost like a graphing paper and filling the boxes as you can see. So if you have just one point, you'll just fill one box. Vector format, on the other hand, use coordinates. So there are points, okay? If you have to show this one point of cell in vector format, you would just plot it on X and Y axis and put that point right in that position. And if you had to make a line, like show a road or something, then in raster format, this is how you would be doing, okay? And in vector format, this is how you would be doing it. So you can see the difference. In raster format, to make a polygon, this is how you would be creating a polygon. In vector format, the polygon will look something like this. Okay, so these are the two differences. Vector format data is like drawing the street and parcels as a set of separate polygons. Okay, raster format is like making one surface by coloring the entire area around that street so that all the street areas and the adjoining parcel areas are covered in their own representative colors. So the idea behind a raster format is you can color different things differently to show that this is the area, this is the exact area. And as we saw in the previous diagram, whatever was colored black was the street, whatever was outside it, you can consider that as nearby areas. So you can, and you don't have to stick to black and white. You could have your own colors, and because of that, you end up having so many colors within your diagram. Now, this is another comparison of vector and raster format. So imagine that this is your street. Maybe surrounding it, there is some playground or something, so you can show it with green like this. Okay, and surrounding it, maybe this area is some sort of a road, so that you can show with a different color. And this yellow part, of course, is your street. Now, the same thing you could show in the raster format in this manner. Okay, maybe the blue things shown here could be your buildings and doors and all those things. So this is what it would look like. If you use GIS to create maps that show municipal boundaries, land cover, roads, attractions, or any distinct spatial features, then this type of spatial data is best stored in the vector file format. So if you want to show all these things, lines and boundaries and roads and attractions, then the best way to fit all that in is using a vector file format and not a raster file format. If you need to perform complex spatial analysis of multiple attributes for each feature in your dataset, then keep your data in vector format. Vector data covers only the spatial areas where each discrete feature from your dataset is located on Earth. But with vector data, you get a lot of options on what attributes of that feature you want to analyze or display on a map. So vector data, vector format has all these benefits. So you have to decide which one you would want to choose. Okay, the easiest way to analyze several attributes that could be derived from one or several features that spatially overlap one another over a particular piece of land is to put your data into raster format. So if you have lots of polygons overlapping each other and you wanted to analyze several attributes one by one, then you would be using the raster format. Because a raster file can represent only one attribute at a time, you'd layer several rasters on top of each other to see how the overlapping attributes compare in a fixed geographic region. So that is how a raster file is created. You don't just create it all together, you create layers over it. So the first layer maybe contains only the street, all the yellow boxes, and the second layer contains the pink boxes. So this way, all the layers are created. And the purpose of this is that when you have so many layers over each other, then it's easier to analyze each attribute specifically or uniquely. While you can do a similar type of spatial overlap comparison using vector files, raster files are going to give you a full and comprehensive coverage for each set of attribute values across an entire study area. For example, to quantify volume data across a fixed area of land, raster files are definitely the way to go. Consider the snow example that we saw in the previous video. Okay, here your attribute is snow height, right? So if you have to quantify volume data across a fixed area of land, then raster files are the way to go because you could show different colors. Okay, to show that the snow height is more or less over here, you could use different colors in raster format, and you could also um, make more boxes to show that the height of snow here is more. Given that your raster data provides you all height data for the snow on a pixel by pixel basis in a particular fixed region, you can use that to calculate the volume of snow on the ground in that area. How do you do that? Because everything is a box, everything is a square, and you know that from the colored squares that this much area is having snow. So you could calculate the volume of snow by simply multiplying the area of each pixel by the difference between the average snow surface height and the average ground elevation at that location. And then to find the area of snow that has accumulated in a fixed area, sum up the volume of snow that has fallen in each pixel of that area. When you work with spatial data that's in vector format, you're focusing on features. You're doing things like drawing separate line features, cutting existing features, or performing a buffering analysis to get some determination about features that are within a certain proximity of the feature you're studying. And when you work with spatial data that's in raster format, you're focusing more on surfaces, not features. So you're working with a raster surface that covers the entire spatial area you're studying and describes the quantities, intensities, and changes in value of one attribute across an entire study area. So it's not a group of attributes, it's just one attribute that you are trying to study when you are using a raster format. It is possible to convert a vector feature to a raster surface. Okay, it's possible you can do that, but you can only convert one attribute at a time because vector can store several. For example, imagine if you have a vector file that represents gas stations with leaking underground storage tanks represented as points on a map. Okay, so it's a map of gas stations and specifically stations with leaking underground storage tanks, which are shown on the map as points. Okay, the vector file. Now the attribute table for this layer has data on the following 4 attributes. Okay, the table, you also have a table accompanying it. So just like we saw in the previous introductory video, there is an accompanying table with this vector file, and it contains all the attributes. And the attributes are here tank was installed, here leak was detected, the depth of that tank, and containment concentrations. Okay, these are the 4 columns in that table. When you convert all of this data from vector to raster, you get 4 separate raster files, not one, okay, because you have to show all these attributes. And so you would be creating 4 files because 4 attributes are there. The vector point format is converted to a raster surface that covers the entire study area and displays the attribute values or lack thereof on a pixel by pixel basis. So I hope you understood all the file formats in GIS. In my next video, we will discuss more about GIS. So I'll see you there, and thank you for watching.